So hi guys, I am Margot Yanko, and for today's video, we're talking about the population. So the population is the number or the size of the a specific thing in a specific location or a specific situation. And population, it uses a exponential growth or exponential decay. And exponential growth and decay has a formula of A is equals to PERT, where A is the final size or the size after the year gap or after the growth or decay, and P is the initial number or its initial size before the growth or decay, and E is the Euler's number or the natural number, and R is the rate of the growth or rate of the decay, and the T is the time gap or the time between the initial and the final year or final date. So these populations are commonly heard in a census, and in a research manner, and they commonly use as population or sample. Sample is the smaller size of population, while the population is the whole size of the um, respondents. So here's some example of population and solving problem. So for our first example, we have a sample problem. A biologist is researching a newly discovered species of bacteria. At time 0, he put 100 bacteria into what he has determined to be favorable medium. So 6 hours later, he measures 450 bacteria. So the question is, what is the rate of growth of the bacteria? So for the first step, we have to determine all the given. So first, the formula is P is equals to, or A is equals to P E R T, or A stands for um, the population after the year gap, then P is the initial population, E is the Euler's number, then R is the rate of growth, then T is the time gap. So um, according to the problem, P is equals to 100, then T is 6 hours, 6 hours, then TA is 450 bacteria, and the question is the rate of growth, so R is the unknown. So to solve the formula, we have to substitute. 450 is equals to 100 E times R raised to R times 6. So we have to divide both sides by 100 to remove the 100 here in this side. So we will get 4.5 is equals to E raised to R times 6. Then to get the value of R, we can use a properties wherein our logarithmic property. So in 4.5 is equals to 6R. So then all over 6
over 6. Then r is equals to 0.25, or r is equals to 25%. So each hours there is a 25% per hour growth for the bacteria. So our next example, there are 20 rabbits on an island. After 6 months, the number of rabbits increased in hundreds. How many rabbits will be there after a year? So first, we need to get the rate of growth. So, like in the first example, um, P is equals to 20 rabbits. 20 rabbits. Then after 6 months, so the time gap to get the rate is 6 months. Then A increases in hundreds, so it's equals to 100. Then so to solve the rate of growth, so A is equals to PERT. A is the final population, P is initial population, E is the Euler's number, R is the rate of growth, and D is the time gap. So 100 all over A is equals to 20 times E, or the Euler's number, raised to R times 6 months. So divide both sides by 20, so we will get 5 is equals to E raised to R times 6. So like in the first example, we can use the natural logarithmic property. So ln 5 is equals to 6r. So divide both sides by 6, then r is equals to 1.61. So since we have the rate of change, we can solve now the real question, which is the number of rabbits after a year. So now the time to is equals to 12 months, since 1 year is equals to 12 months. So A is equals to 20 rabbits times Euler's number raised to 1.61 percent, or 1.61 times 12 months. Then we will get so the final population is 4915856, or 858642, or 4,915,858,642 number of, or population of rabbit. So our last example, there were 80 dodos living on an island. After 5 years, the number of dodos had decreased to 55. Then the question is, how many years before the dodos become extinct? So in this problem, we are looking for the time. So first, P is 80 dodos, and it says first we must get the rate of change. So like in the first and second example, um, there are in time 1, or the first time is 5 years. Then after 5 years it has decreases into 55. So a is equals to p e r t. So a is 55 is equals to 80 e r t. So divide both side by 80, then we will get 0.69. E is equals to e r t. Then the natural logarithmic properties, and ln 0.69 is equals to r, so we can substitute the t. R times 5, so divide both side by 5, then r is equals to negative 0.074, negative 0.074. So this is the rate of change, negative, since the population decrease. So now we can solve the real question, which looking for the time before the extinction of the dodos. So since extinct is 0, so there's no dodos at all, then the time is missing. So a is equals to PERT. So a is 0, so equals to 80 ERT. So 0, 80 E, so the R is negative 0.074 times T. So divide both sides by 80, and still 0 is equals to E negative raised to negative 0.074 T. Then the Euler's, I know, the Lin theorem